Hello everyone, I welcome you all to this lecture. In this lecture, we are going to discuss a very important topic, that is SR flip-flop. Flip-flops are sequential circuits. They have memory element. So the output of the flip-flop is dependent on present input as well as the previously generated output. So quickly let's draw the diagram of SR flip-flop. SR latches with the help of NOR and SR latch, which we can construct with the help of NAND, we have already discussed in the previous lecture, right? So to understand SR flip-flop, we need to have the knowledge of latches. So if you haven't gone with the previous video, please go through it. So let's draw it. Okay, so when we draw the circuit for SR latch using NAND flip-flop, somehow it will look like this, and we connect this input to this output and this output to this input, right? But in the previous lecture, I have told you there is a difference between flip-flop and latch. Flip-flop gets clock, and based on the clock, the circuit gets activated. So how do we pass that clock? So let me copy this. Let's say this is the circuit. Now we are having here like this. Okay. Now the connections, you can make something like this. So this input and this input, we are connecting to these outputs. Okay. So we can connect it like this, or this is connected like this. So you are already aware about this. The only difference which we are making here, we are passing a clock pulse. So the clock which we are passing here. So let's say here we are passing a clock. Okay. So there is a clock. This is S pin and this is R pin. And these values we are passing and connecting here. So we connect this thing. I can take some different color like this. And let's say directly I'm connecting this to this and this point to this. So the connection is like this. We are already aware about this box is SR latch, which we have constructed with the help of NAND gate. So if I draw a box here, so this circuit is representing SR latch, which has been constructed using NAND gate. And if I draw a box like this, then that will be considered as a SR flip-flop. So this green box is representing SR flip-flop, and this white box circuit is representing latch. We have already discussed that this pin is representing Q and this is representing Q bar. Here whatever we are getting, I'm giving different names. So here let's say this is S star or R star asterisk, or you can say it is S dash or R dash. It is representing like that. So this is the diagram of SR flip-flop. Now let's draw the truth table for this flip-flop. So you first try to understand what is S star and R star. So if I consider S star actually it is clock dot S bar, and R star is clock dot R whole bar, the complement of it, right? Because these are NAND gates. So if you open this, it will become clock complement plus S complement, and this will become clock complement plus R complement. So please do remember, it will help you to understand what S star and R star values we will be getting based on the value of S and R. Now if you can recall the truth table of this ledge, let me quickly draw that. So this truth table look like this, which we have already discussed in the previous lecture, right? So this is 0 0 actually. When we pass 0 0, what happens? In case of 0 0, we pass 0 here and 0 here. In that case, the 0 will give us, okay, so this is invalid actually. In case of when we are using NAND gate, this is invalid, and this will represent the memory. Okay, so this is invalid because both Q and Q bar will give us value as 1. So this is invalid in case of NAND latch, and this will give us the previously generated state, so it will act as the memory element, or it will preserve the previously generated state. So that is there. Now if we want to draw the truth table for this SR flip-flop, so in order to draw this truth table, let's draw it. Okay, so in the truth table of SR flip-flop, we'll be having the major role is of clock. So let's say I'm writing here clock. Based on the clock, the circuit gets activated. Okay, so until and unless clock will be high, the output will not change, and flip-flop will retain the previously generated states. So that you people are clear, right? Now if you assume clock is 0, so in case clock is 0 and we are having S pin and R pin, and we are having, let's say, Q n plus 1, the newly generated state n plus 1. So if clock is 0, then whatever the input we pass here, that becomes don't care, and it will preserve the previously generated state, that is Qn. So Qn plus 1 is the next generated state or newly generated state, and Qn is the previously generated state or the output, right? But in case clock is 1, in that case it depends upon what values we are passing. So let's consider if you are passing 0 0. Now look at the circuit. So if we are passing here 0 0, let's write it. I'm giving, let's say this is 0 and this is also 0. So when we pass this 0, the 0 will come like clock is 1 only, so 1 dot 0 will give us 0, and the complement of 0 will give us 1. So that means here we will get 1, and this R is equal to 0 will also convert it to 1 here. So ultimately we will get here 1 1, and in case of 1 1, this SR latch, which is designed by using NAND gate, will act as memory element, like this case, right? So although we are giving here 0 0, but it is getting converted into 1 1, and this will act as the memory element. So if it is working as the memory element, it will preserve the previously generated state. So here it will get Qn only, because previously we are assuming that Qn has been generated. So Qn plus 1 will be equal to Qn only. But the third case, let's say clock is 1, and let's say you are having S as 0 and R as 1. So go back and analyze this situation when S is 0 and R is 1. So when here S is getting value 0 and R is 1, so when S is 0, this will become 1 here. So this S star will become 1. And because this is 1, so if this is 1, and this one, and the clock is also high 1, so 1 1 will give us 0 here. That means we are passing 1 0. So in this, when we pass 1 0, we will get S0, right? So the new state will be generated as 0. When we pass 1 0, this is 1 and this is 0, we will get 0. So the Qn here, we will get Qn plus 1 as 0, right? Now the next case, in case we send the value of S as 1 and R as 0. So let's look at the circuit. If we are having these values, S as 1 and R as 0, so when this is 1 and this clock is high, so this is also 1, we will get here 0. So this S star will give us 0, and this R star will give us what? This is 0 and this is 1, so 1 0 will give us 1. And if you look at the truth table of this SR latch, when it is getting 0 1 0 1, the output is 1 only. So here we will get output as 1. Now the fourth case, when clock is high and both S and R pin are also high. So let's look at the circuit diagram. Now when S is high and R is also high, let's find out what will be the output. So S is 1, R is also 1. So when this is 1 and this is 1, this S will become 0, S star will become 0, and when both are 1, clock is high and R is also 1, this will also give us 0. And when we pass 0 0 in this SR latch, it is invalid state. So this will give us invalid. So we can write it as invalid. So this is an invalid state, and this is the truth table of SR flip-flop, right? So please do remember, this is very, very important. After this, I'm going to draw, there are two more tables. So one is the characteristics table and another is excitation table. So let's draw both the tables. So in characteristic table, we consider the previously generated state. So let's say this is Qn. We also consider S and R, and then we try to find out Qn plus 1. So these three are input which we are passing, and we are analyzing the behavior of Qn plus 1. Okay. Now let's draw it. When there are three input I'm considering, there will be 8 combinations. So here I'm not considering like enable line, you understand, the clock. Okay. So the combination will be like all three as 0, then 0 0 1, it can be 0 1 0, it can be 0 1 1. then 1 0 0, 1 0 1, 1 1 0, and 1 1 1. So there are 8 possible combinations. Now the very first combination, when Qn is 0 and S and R are 0 0. So when S and R both are 0, clock we are already considering as 1, it is high in all these 8 combinations. So 0 0 is working as the memory element because it is giving only Qn. So if Qn was earlier it was 0, it will again give us 0 only, right? So we will get 0 here. Now in this scenario, when Q S is 0 and R is 1, so S is 0, R is 1, it generates 0. So irrespective of the Qn, it generates 0. So this will also give us 0. Now when S is 1 and R is 0, S is 1 and R is 0, this will give us this will give us 1. So this place will give us 1 irrespective of the previous value of Qn, the output will be 1 only, right? But in this fourth case, where S and R is 1 1, so in case S is 1 and R is 1, it is an invalid irrespective of the previously generated state. So you can say this is cross or invalid state, right? Now the next is when Qn is 1, both 0 0 will preserve the memory. So 0 0 will give us the previously generated state and it is 1 here. So we will get 1 here. Now 0 1, 0 1 will give us 0. So we will get 0 here. 1 0, 1 0 will give us 1 0 will give us 1. So this is 1. And 1 1 is again invalid. So this is X, let's see. Now this is the characteristics table of SR flip-flop. Now there's another table which we consider as the excitation table, in which we do consider the Qn and Qn plus 1 and we try to predict the input S and R. So let's draw that table. So in excitation table, we take Qn, previously generated state or output, and Qn plus 1 as input, and we try to analyze the value or predict the value of S and R, right? So if there are two inputs we are considering, there will be 4 possible combination like 0 0 0 1 1 0 and 1 1. Now we can easily get the value of SR. So when we are having 0 0, Q is 0 and Qn plus 1 is also 0. So let's find out. Qn is 0 here and Qn plus 1 is 0 here. Is there any other combination? Yes. Qn is 0 here and Qn plus 1 is also 0 here. S is getting value 0 only. So S will get 0 and R is getting either 0 or 1. So R will become don't care, because R is getting both the value 0 and 1 in different situations. So R is don't care. I hope you are getting it. So then the next scenario, let's try to understand. Next is when Qn is 0 and Qn plus 1 is 1. So Qn is 0 and Qn plus 1 is 1. There is one scenario like this, and that's all. So in that case, S is 1 and R is 0. So S is 1 and R is 0. Now let's clear this. The third scenario is 1 0. So when Qn is 1, Qn is 1 and qn plus 1 is 0. So qn is 1, this is, and n plus 1 is 0. Is there any other combination? No such combination. 1 0. So s will get value 0 and r will get value 1. So it is like possible when s is 0 and r is having value 1. Now let's again clean it. And then the last combination 1 1. So when we are having 1 1, both are 1. Here it is 1 and 1. And here it is also 1 and 1. So these two cases, when qn is 1 and qn plus 1 is also 1. Here r is fixed in both the condition, r is 0 only. So r will be 0. But if we look at the s is changing from 0 to 1. So s will become don't care. Okay. So all these tables are very important. And please do remember these tables. When we solve the problems, we need to recall all these three tables. So for this lecture, it is sufficient. I'm ending this lecture. Thank you everyone for listening.